There is an unusual volcanic phenomenon that continues to attract the attention of researchers deep in the frozen expanse of Antarctica. Mount Erebus, the tallest and most active volcano in Antarctica, keeps spewing a fortune in pure gold into the Antarctic atmosphere every day. Antarctica, the southernmost continent, is known for being cold and inhospitable, but thousands of years ago, many volcanoes spewed their lava and hot vapors into the atmosphere. This happened before it got cold in the Antarctic. Mount Erebus is a volcano that has survived the cooling and has many surprises. Rising 2,448 feet in elevation, Mount Erebus is considered the southernmost active volcano in the world. Located on Ross Island, approximately 840 miles from the geographic South Pole, the volcano has erupted constantly since 1972, regularly emitting plumes of gas, steam, and occasionally rocks. The volcano has a constantly bubbling permanent lake of blazing lava at one of its summit craters, which is quite rare, as it requires some very specific conditions to be met to ensure the surface never freezes over. The glacier-covered mountain was discovered in 1841 by Sir James Clark Ross during the expedition named after him and after the HMS Erebus, the flagship of his two-ship expedition fleet. When the Ross expedition arrived on the island, they witnessed an eruption of the volcano. The mountain was first climbed in 1908 by a group of participants in the British Nimrod expedition led by Sir Ernest Shackleton. Among the climbers were the well-known Antarctic explorers Douglas Mawson and Tanat William Edgeworth David. Along with the release of gases from the underworld, the inclusion of crystallized elemental gold from the volcano is a very rare and strange characteristic among known active volcanoes. This is because to date, Mount Erebus is the only volcano in the world known to spew forth crystalline elemental gold particles. Veins of exposed magma on the surface of a volcano can reach 1,000 degrees Celsius, but cooler areas can harbor gold particles, which travel upward from deep subterranean deposits in many volcanic events. Most other volcanoes melt these particles during eruptions, but Erebus is different. It is thought that when the frigid Antarctic air, where temperature can reach -50 degrees Celsius, skims the scorching surface of Erebus lava lake, the conditions for solid gold materialize. Researchers have estimated that approximately 80 grams of gold is being expelled this way by the volcano's emissions, creating an estimated $2.2 million per year, or about $6,000 per day in airborne riches. The fine gold particles, along with the gases released by the volcano's crater, gets caught in strong polar winds, and some of the gold particles can travel up to 1,000 kilometers before depositing on the Antarctic ice. The daily emission of the metal, however, remains practically invisible to the naked eye because the gold does not appear in nuggets, bars, or visible fragments. Instead, the gold is found in extremely small microscopic crystals, so small that at only 60 microns, the gold flecks are much smaller than the thickness of a human hair. The presence of the metal has been documented by researchers for decades and published in scientific journals since 1991. During the study, the researchers analyzed gases, atmospheric particles, and materials collected near Mount Erebus. This resulted in the identification of elemental gold crystals in the volcanic plume, in the suspended particles, and in samples close to the surface. According to the researchers, the amount represents only a small fraction compared to the total volume of materials emitted by the volcano. Nevertheless, the crystalline structure of the metal makes the discovery particularly unusual for the scientific community. Other volcanoes worldwide, such as Kilauea in Hawaii, Etna in Italy, Augustine in Alaska, and El Chichon in Mexico, also emit trace amounts of gold, but Mount Erebus is unique because it releases pure, crystalline gold instead of chemical compounds. Studies have suggested that gold can be transported in hot volcanic fluids and likely gases too, which makes sense because a volcano is basically a hole in Earth's crust through which molten material from deep below the ground seeds upward. Many elements such as copper, silver, mercury, arsenic, selenium, and sulfur, as well as gold, are all thrown together in a literal melting pot where they can join with other elements to form compounds. From there, the gold isn't evaporating like water from a kettle. The boiling point of pure gold is far hotter than volcanic temperatures. Instead, it is thought to hitch a ride in volatile chlorine or sulfur-bearing compounds that can exist in the hot volcanic gases. Since the Erebus gold is doing something not seen in any other volcanoes, researchers have collected samples from the snow around the volcanic crater, from the plume of gas coming from the lava lake, and from the Antarctic troposphere up to 1,000 kilometers from the volcano. In all three sample sets, researchers found micron-scale particles of pure gold. When the particles were viewed under an electron microscope, they appeared as intricate, faceted, almost perfectly geometric crystals rather than irregular specks, some measuring up to about 60 micrometers across. This characteristic differentiates the crystals from the irregular mineral fragments frequently found in natural environments. The estimated daily output of 80 grams is also actually somewhat smaller than that reported for some other volcanoes. Based on measurements available at the time, Kilauea emitted an estimated 500 to 800 grams of gold per day, while estimates for Etna reached as high as 2.4 kilograms. So what is happening at Mount Erebus that allows the gold to separate from the compounds that held it in the volcanic emissions? One theory the researchers have proposed is that gold is carried out of the lava in volatile chlorine or sulfur-bearing compounds. As the gases cool, the gold crystallizes out of these compounds before eventually coming to rest on the Antarctic ice. One difficulty with that theory, however, is that the gas contains very little gold. Under those conditions, the spontaneous nucleation of perfectly formed crystals in the air is very difficult. Another scenario is that the gold forms more gradually in a crust on the surface of the lava lake before being borne aloft by rising gases. The complete process, however, has not yet been definitively clarified, and the exact chemical process remains an active area of scientific debate. Mining this treasure is also virtually impossible, as the gold is highly dispersed across the vast, inhospitable polar ice. Mount Erebus is located in an extremely remote region. Severe climatic conditions, with intense winds and very low temperatures, hinder any operation. Attempts at any exploration would face significant logistical challenges. Under the Antarctic Treaty, extracting natural resources from the continent for commercial purposes is also strictly prohibited. The size of the particles represents another relevant obstacle. The gold has microscopic dimensions, measured in micrometers. Separating the material would require a complex industrial process, and the cost of the operation would outweigh any possible economic benefit. Scientists speculate that installing a specialized filter directly above the volcano could potentially collect the valuable gold particles over the long term, however. Mount Erebus thus represents more than just a natural wonder. The existence of this active volcano reinforces the complexity of Earth's natural processes. The golden plumes continue to drift silently across the southern ice cap, demonstrating the planet's spectacular and unpredictable geochemical systems. The combination of lava lake, continuous activity, and release of metallic particles keeps the volcano among the most peculiar ever studied. Researchers use the site to study the relationship between heat, pressure, and metal formation. This data helps understand the behavior of elements within the Earth's crust that continue to surprise modern science.